Welcome back to Maths with Mrs. J. We've been talking about logarithms. We're finally up to the point where I want to teach you how to use your calculator to calculate logs to base 10. Remember I said if it is to base 10, quite often you won't see the base written. So for example, here we have log of 84. If there's nothing written, we assume that's a base 10. Now, a lot of schools use this calculator. You will find a log button near the top on the left there. It will just say log. Underneath it, by the way, is the natural log button, which I mentioned in our previous videos. That means log to base E. But for today, we're just working in base 10. All right, quite easy to work these out. We just need to use our button and round off accordingly. So if we are calculating log of 84, we just press, just make sure that our calculator is clear, and we just do log button and then 84 and then enter, and to 2 decimal places, that's 1.92. So these are approximations, not exact answers, of course. But because they said to round off to 2 decimal places, that's perfectly fine. We should always think when we get an answer, whether that answer makes sense or not. Does it make sense that log of 84 is 1.92? Just remember, what does log of 84 mean? What it means is, what do you raise 10 to give you 84? Now, we know that 10 to the 1 is 10. We know that 10 squared is 100. 84 is between 10 and 100, and it's closer to 100 than it is to 10. So it makes sense that the index that we need is going to be between 1 and 2. So yes, that is a perfectly feasible answer. Always a good idea to check, just in case you've accidentally hit the wrong button on your calculator. All right, next one, log of 1023, and we get to 2 decimal places, we're going to get 3.01. Again, that's an approximation. You can either, for an approximation, do an equal sign like that, which is very handy if you've already got an equal sign there, and then you say, well, it's not actually equal, it's only approximately, or you can use your 2 squiggly lines. Either way is fine. Does that make sense? Well, yes. 10 cubed is 1,000, and this is just a little bit bigger than 1,000, so it makes sense that our index will need to be a little bit bigger than 3. All right, let's make predictions about this one. 0.009 is very close to 0.01, isn't it? Which is 1/100th. What do we raise 10 to? Let's just think about this. What do we raise 10 to get 1/100? Well, it's a fraction, so it's going to be a negative index, isn't it? It's in fact going to be -2 to get 1/100. Let's actually fix that up there. And then we can actually use our calculator. And so we should be getting an answer roughly around that. Let's have a go. So log of 0.009 is -2.05 if you round off to 2 decimal places. As I said, always a good idea to have at least some idea of what sort of answer you're expecting. Now, the next question is really doing exactly the same thing. It's just asking it in a different way. They're saying if 10 to the x is these numbers, find x. So for the first one, what we're saying is 10 to the x is 7. What is x? Well, remember what I said about logs? The log is the index. X is going to be log of 7 to base 10. And of course, we don't have to write the base 10. So we're just doing the same thing that we just did, really. So log button and 7. But in this case, we wanted 4 decimal places. So 0.8451. So again, do an approximation there. This one here again, so the answer will be log of 98. Now 98 is nearly 100, isn't it? And 100 is 10 squared. So we're expecting an answer that's going to be nearly 2. Let's see how we go. Log of 98 is 1.99 when rounded off to 2 decimal places. And our last one here, we've got a fraction. This fraction is a little bit bigger, well, reasonable amount bigger than 1/10, isn't it? 1/10 is 10 to the negative 1. Let's have a look and see what we get here. So log of 0.179, and we get our x here is going to be log of this, which is approximately negative 0.7471.